Hello, we are taking a look at Chapter 19, Assignment Problem 6. A student said they've been working a long time on this and couldn't get the right answer. So here are the correct answers, or here are the answers that the author considered to be correct. Jot these down so that you can enter these in and get the points for this problem. I will tell you up front that the answers given in Section A are actually incorrect. And here's the reason why. If you read through the chapter 19 and understood that these answers are based on the binomial probability distribution for C equal to 1, 2, and 3, what you understand from reading the concept in chapter 19.3 is that acceptance at a level of C equal to 1 should also include the probability of C equal to 0. The author who calculated these numbers and determined what he or she thought was correct did not include the probability that C is equal to 0. Let me demonstrate. If you open up your toolkit to the binomial probability distribution, and in the first instance, we have a probability of, in this case, success, which is equal to a defective item. In the first instance, they used a probability of 0.02. Now, the probability of having exactly one defect out of a sample of 20, if the probability of a defect is 0.02, the probability of exactly one defect is 0.2725, which is the answer that the author considers to be the correct answer. However, if we're looking at a sample of 20 items, we're going to accept it if C is equal to 1, but we're also going to accept it if C is equal to 0. In other words, if you have no defects, that's also going to be an acceptable sample. But they completely disregard the probability of having 0 defects, which in my opinion, and in the opinion of the textbook, would be incorrect. The probability of accepting C, 1 defect, or 0 defects would be the cumulative probability of both of these added together, or 0.9401. But that's not what the author considered to be correct. If that's what you entered originally and had it marked wrong, you were actually right. The author was wrong. But we have to go along with what their thinking was, even though it's incorrect thinking. I'm in the process of writing a message to the textbook publisher to let them know that this is an error, which is why I say go ahead and jot these numbers down so that you can get your points. Now, for C equal to 2, however, they do use the concept of cumulative probability, because at a level of 2 for a probability of 0.02, they take the 0.2725 and add it to the probability of C being equal to 2. So they take the 0.2725 and add 0.0528 in order to get the 0.32 0.3253. Likewise, they take the 0.3253 and add the probability that C is equal to 3, in order to get this 0.3318. So the 0.3253 plus 0.0065 gives you the 0.3318. And they do this for each successive value of P, which you should be able to see. The problem is they don't include the probability that C is equal to 0 when they calculate the probability that C is equal to 1, which they should. In part B, we define two different probabilities. The probability of the acceptable target defects, in this case 2% of 0.02. So the probability of acceptance in this case is the same as the probabilities of acceptance that we got here, even though they're not actually correct. The producer's risk is simply 1 minus the probability of acceptance, because the producer's risk is the probability that this lot will be rejected. So the producer's risk is the probability of making a type 1 error, which is simply the probability of rejecting this lot using a sample size of 20 and a probability of 0.02. So again, take these numbers, subtract them from 1, it gives you the producer's risk. The P1 is the probability of accepting a lot that actually has this higher number of defects. So you use these acceptance numbers from part A, the probability of accepting that higher lot, the probability of accepting that lot that has a higher level of defects than what you'd like to accept is the consumer's risk. This is the probability of making a type 2 error. So I'm sorry if you struggled with these. My apologies. It was a mistake made by the producer, the author of this problem. Sometimes happens with publishers, but obviously these probabilities don't agree with the concept because it leaves out the probability that C is equal to 0, which would obviously be acceptable if you have an acceptance of 1, 2, or 3.